Okay, I'm going to do a super hard distance, rate, time question, then I'll do some easier ones that were from the warm-ups. So we got a snail and a turtle that are training for a marathon. The turtle usually runs 5 meters per hour faster than the snail. They have a combined workout of 8 hours, so maybe like one does 1 hour and one does 7. And if the snail ran 30 meters and the turtle ran 20 meters, how long did they each exercise? So I like to organize these in these distance, rate, time boxes. So the snail ran 30, and the turtle ran 20. We don't know their rates, although if the snail ran X, turtle's going to run X plus 5, because 5 meters per hour faster. And then finally, the times, well, time is distance over rate. You can see that there. So that's going to be 30 over X, and this is going to be 20 over X plus 5. And the way these problems have typically worked, those two things are equal to each other, but they're not here. They add up to 8. So just you're going to change my equation. So I got 30x plus 20x plus 5 equals 8. So I'm going to multiply through by x to cancel those. And I'm also going to multiply through by x plus 5, x plus 5, x plus 5, which is going to cancel that. So what I'm left with here is the 30 times the x plus 5. I'm left with the 20x, and I'm left with 8 times x plus 8. So that's my equation that I have to solve. So I'm going to pull some scratch paper out here and continue this. Okay, so that's going to be 30x plus 150 plus 20x equals, it's going to be 8x squared and 64x. No, I wrote something down. That's a 5. Can't read my own handwriting. That should have been a 5. That's a 5. And so that's going to be 40. Okay, 40x. All right. And then I'm going to get everything to one side of the equation. So I'm going to have 8x squared. This is going to be 50x, but when I bring it to the other side, it'll be a minus 10x. And I'll bring that to the other side, and it's a minus 150. So that's what I've got. Try to make this a little simpler. If I divide out a 2, I get 0 equals 4x squared minus 5x and minus 75. Now, maybe this is factorable, but I think it's just going to be easier to use quadratic. So we're going to use quadratic. So the opposite of the negative 5 plus or minus negative 5 squared is 25 minus 4 times 4 is my A, negative 75 is my B, all over 2 times A. So this ends up being 5 plus or minus. When I evaluate all that, it's 1225, and then the square root of that is actually 35. So it's 5 plus or minus 35 over 8. The 5 minus 35 is going to give me a negative number, which doesn't even make sense. The 5 plus 35 is going to give me 40 over 8, or 5, which means, if I go back to my original problem, this would be 5, which means this would be 10. And 30 divided by 5 is this up here. 30 over 5 is 6 hours. And 20 over 10 is 2 hours. And that adds up to 8. So the snail ran for 6 hours and the turtle for 2 hours. So easy, isn't it? Not really. Okay, so here's just a little review. You've seen these already. They were warm-ups. I'm just going to set them up, and I'm going to let you finish them. So read that. It's a little hard because it zoomed out. 50 miles for a car, 10 miles for a bike. The car's average rate is 20 miles per hour, more than the bike, so it's not 20 miles per hour. It's more. How fast is each one traveling? So car's going 20. No, not 20. 50. The bike's going 10. My rate is I don't know, but I know that the car is going, if the bike is x, this is x plus 20. And my time is, once again, distance over rate. So 50 over x plus 20 and 10 over x. So my equation is 50 x plus 20 equals 10 over x. Going to cross multiply, get 50x. The 10 times the x plus 20 is 10x plus 200. And ultimately, when I divide that, it'll be x equals 5. I'm running out of time. I'm going to stop it there. And so 25 for the car, 5 for the bike. That all checks out. All right, last one. We've got a, this is actually probably the easiest one. We're doing it last. It was a warm-up. A slow horse and a fast dog are identical speeds. They start from the same point. The horse starts walking 2 hours before the dog. They both stop at the same time. The horse has gone 25.2 miles. The dog has gone 16.8 miles. What were their rates? So go ahead and try that real quick. I suggest organizing it in the distance, rate, time box here. So our horse was 25.2. Our dog was 16.8. Our rates, we don't know. But we do know if we make the horse x, we can make the dog x minus 2. Or if we make the dog x, we can make the horse x plus 2, because the horse is going to walk 2 hours longer. Always important to think about which number you want to be bigger. Rates are identical, and we know that rate is equal to distance over time. So we got 25.2 over x plus 2, and we have 16.8 over x. Those two are equal. Sometimes these will add up to something, but in this case they are equal. So I can do 25.2 over x plus 2 equals 16.8 over x. I can cross multiply, or basically multiply both sides by x and get 25.2x. On the other side, I'm going to get 16.8 times x plus 2 when I multiply both sides times x plus 2 and eliminate it from the left side. And then I'm running out of room here, so I will grab some scratch paper and rearrange things a bit. So then we've got just 25.2x equals 16.8x and 33.6. I can minus the 16.8x from both sides. Am I still on the screen? I am. And that's going to give me it's going to give me 8.4. X equals 33.6. And then when I divide by the 8.4 and 8.4, I get x. Or sorry, get x equals 4 down here, which is, the dog's speed is 4, not speed, time is 4, and the horse's is 6, and that wasn't the question. The question was, what is the rate of each? So if I do 25.2 divided by 6, or 16.8 divided by 4, they should give me the same number, and they do. They are both walking at 4.2. Oops, can't see. They both give you the same thing. They both give you 4.2 miles per hour. That's it. Ciao.